Okay, so how do we figure out a phase shift on one of these sinusoidals? Well, I'm looking. This is out of that Lippman textbook, and you guys don't have a copy of this physically because I don't think you took one, but you can go online and grab a copy, and when I'm done here, I'll make sure I include that. So this is on page 409, and I see a bunch of graphs here. This is in section 6.1 in the homework part. This is just like, this is where I get your problems to do in the paper. So I see a midline right here. I see a sine graph. I also see that that sine graph starts right on the midline. It's just normally it would be up here at the origin, right? It's just shifted down 4 units. So that has no phase shift. Okay. Then here's another one, similar kind of question, only shifted down 3. I look at the next one down here. Let me clear this, clear all this drawing. Come back so I have. And here's a couple of cosine graphs. Let's see. So here I see the midline at y equals 1, and it peaks. That cosine graph starts on the y-axis, so that doesn't have a phase shift either. We could do a couple of things. We could do this one. I mean, I could say, I wouldn't do this, but I could say, okay, this cosine graph starts there, so that means it's shifted to the right 2 pi. So what I would do is I would do cosine. Let's see, what's the period of this? The period of this graph is 4 pi, right? Because that's how long it takes to repeat. So 2 pi divided by 4 pi is 1/2, right? And if we're going to go with this point, well, let's do the one that's the easiest. This is no phase shift, so I'm just going to put an X. It has an amplitude of 2. There's 2 above the midline, 2 below the midline, and then it's shifted up 1, right? So that's one possible equation for this graph. We could also go with this one, and this graph has been shifted to the right 2 pi. So what I would write would be 2 cosine, because the amplitude is still the same. And I know the period is 1/2, or the B number is 1/2 because the period is 4 pi. But then I'd have to say x minus 2 pi because I shifted it 2 pi units to the right. And then of course I would need to do the plus 1. And then because of this one, it's been reflected around that midline, so I got to make it negative. Okay, so that's what you do with a phase shift. You look at how far off, like the y-intercept is, or the y-axis. That's one way. That's one of the first things I look at. Let's scroll down and look at a couple of others in this homework exercise set that has some phase shifts. See, that's just this. I would call that a sine graph that's been reflected around. So I would say negative sine with the period here. 3. So well, why don't I do this one before I leave the screen? It doesn't have a phase shift, but so the amplitude is 1. It's been shifted. The whole function has been shifted down 1. So I would say negative sine, and the reason I'm saying a negative sine because it starts there and heads down, and rather than starting there and heading up like the normal sine graph. Let's see. The period is, what did we say? 3. So 2 pi over 3 times x, and then it's been shifted down 1. So that would be an equation for that. Again, no phase shift, but I thought I wanted to do it for you. Let's look at it. Let's come down here and look for some phase shifts. Okay, here's a graph that's got a phase shift going on. And I see, what do I see? I see that goes down 4 from the x-axis, and this goes up 4 from the x-axis, so it's not shifted left or right, up or down. And so the midline is y equals 0. But since that's the midline, you see the way it crosses the x-axis at -1 instead of at the origin. And what is the period of this graph? Let's see, it goes from -1 until -11. That's how long it took to cycle through. So that's a distance of 10. So that's the period. So, and let's see, the amplitude is what, 4? So we're going to say 4 sine, and why am I using sine? I hope you said because it starts on the midline. it has that nice lattice point on the midline. I mean, you could use cosine, but I don't know what number is that. I mean, is that 1.5? I don't know. Maybe, probably, but I don't know that for sure. And so if the period is 10, we know the number in front of the x is pi over 5, right? Because 2 pi over 10 simplifies to pi over 5. And then we get this phase shift going left. So I'm going to say x plus 1. And it's not shifted up or down, so I'm not going to write anything. I mean, I could write plus 0, but why would I? So that's how I figured out that phase shift. I looked, normally sine graphs start right there on the origin, and this is shifted left 1. I could say this is shifted left 11 if I wanted to, and that would be just as right. I could say it's shifted right 4. If I went right 4, it would be -4 sine of pi over 5 times x. What did I say? So -4, because it's shifted right 4. If we were to graph these on Desmos, we would see the exact same thing. Okay, so that's for sine. Why don't I do a cosine for you also? So let's see, I'd call that a sine graph because it starts in the midline, just a different amplitude from the one above. This one, I'm going to go with a cosine because you see the way that here, let me get a pointer, though you probably can see that hand nicely. You see the way instead of starting there at 1, it slid to the left 1. I see the amplitude is 1. The period is what? Let's see, it goes from -12 until -2. So that's a distance of 10. So the period is 10. Now let's do a little work here. Let's see. So I know the period is 10. So the B number is 2 pi over 10, so pi over 5. We said cosine, pi over 5. And then I'm going to say x. Now that's been shifted. Normally cosine starts right there. And this has been shifted left 2. So I'm going to go x plus 2. And it's not been shifted up or down because the midline, the x-axis, okay? And I see the amplitude's 1, right? So I don't have to do that. Yeah, I think that's the graph. I think that's an equation that would graph that function. And this is just like it, right? I mean, 4. Let's see. So that's shifted right 4. You could say left 2. Again, then go cosine. Amplitude is 2 in this case. It's not shifted up or down. So what do we say? 2 cosine. What's the period? It took 6 units to repeat. So pi over 3, right? 2 pi, right? 2 pi, better write that. 2 pi over 6 is pi over 3. And it's shifted, I guess I'll go left 2. So x plus 2. And it's not shifted up or down, so I think that's the equation. What would it be if I used that point and I went right 4? I hope you said 2 cosine pi over 3 times x minus 4. Okay, so hopefully that helps you decide what the phase shift is in a graph. And of course, when you do the equations, why don't I do that? And then I got to remember to go show you where to get this textbook in case you forgot. I did show it to you a couple times. Remember the phase shift, the left-right shift is the phase shift, and that's if you write the sinusoidal in factored form, it's really easy. Like for this one here, that's shifted left 4. This one is right 3. This one's not so easy because it's not in factored form, so you have to rewrite it. And we did some of these with a practice, certainly in the paper exercises. In fact, you probably did this one in the paper exercise. X minus 7. So yeah, I factored that 3 out, divided that by 3, divided that by 3, and then plus 4. So this has a phase shift of right 7 units. Okay? So hopefully that helps you out. Oh, let me go find you the textbook. Yeah, so what you do, how you find the textbook is, let's see, you can just Google, here, let me get this out of the way. If you just Google Lippman, that's David Lippman is the main author, or the first author of the textbook, and just do open pre-calc. You should know this if we're going to, because we're probably going to be online. I don't know for how long. I think it's going to be a while, but I was wrong. So I'm not a fortune teller. So there's the top hit. Just click on that. And let me clear off this eat writing that I did. And let my slow internet connect finally. Yep. Yeah, something about the news, huh? Here we go. So this is the textbook. This is the website you can download. Here's the whole textbook. You can download the whole textbook in PDF form. Don't go buying one. If you want a copy, you just tell the school and we can get you a copy from the school. And then here's the detailed solutions. You want a copy of this because what this does is this is some, you've seen some of these. These aren't mine, but you've seen, I've had you look at some of these for the, on the online exercise that I post. They've got a lot of the work. I mean, let's zoom down to chapter 6 there. They don't have this formatted really well, unfortunately. We are in chapter 2 still there, I think. Let's see. And here's chapter 4 because it's about exponential growth. Yeah, let me try. Let's try. Just I'm taking the time that I want you to see. Okay, now we're into some sine functions. Let's see what section are we in? Oh, here's 6.1. And we 21. See, they got a lot of explanation here. I was just wondering about some of the ones we did, what they show. See, they give a lot of text. I guess they don't have but they do show more than just the answer. So, I mean, it's worth getting a copy of this. It's worth getting a copy of the textbook. Okay, now that you're kind of out there on your own, not that you can't access me for help, but I think this might be something that'll help you. It'll help you become a better student for the next time you're in a classroom. Okay, well, I'm gonna stop this video and upload it and send it along. Give a yell if you need help. But I added all those times onto my appointment calendar, so you can just grab a time. We can do a Zoom app. I'm using Zoom to record this. All right, talk to you later.